All right, so welcome to our presentation. Thanks for being here. We're a Highlight, so we're a platform to help creators build code-based generative art collections. So Highlight kind of helps creators use no-code tooling to deploy collections, create gated content, create a portfolio, kind of survey their content on-chain. But what we're most excited about is code-based generative art. So we're really inspired by artists like Kim Asendorf, who's a popular artist in the generative art space that we're working closely with, because we're going to be launching a platform at the end of this month. So like I said, Highlight kind of offers no-code tooling. With this code-based generative art, you're going to be able to integrate like AI models, GANs. We kind of do all the stuff in the background for you to create like beautiful mint pages and all these sort of things. And this summer, we're going to be collaborating with a bunch of artists and brands just to kind of push the boundaries on code-based generative art. So OpenSea, Coinbase, obviously our friends at ETHGlobal are some of our partners. So today what we're going to do is we're going to help you kind of like, we're going to walk through what it takes to deploy a code-based generative art collection on Highlight. And we're going to switch back and forth with like technical explanations of some of the like cutting edge, like protocol innovations we've made, also some of this new stuff that we've developed on the generative art side. Yeah, and so Sarib's going to walk you through that. But before we jump into creating a collection, I just want to show you like what an end product looks like. So if you come to Highlight and create a generative art collection, we're going to create this kind of like mint page for you. So this is kind of like your typical collection on Ethereum or on an EVM chain. And the way that it works is when you mint a token from this collection, what we do is we take a bunch of parameters from the transaction, the mint transaction, like the transaction hash, the block hash, the token ID, the timestamp, like all these different sorts of things. We input it into the script that the artist initially uploaded, so the actual like generative art script. And with that custom input that's unique to your transaction, that script is going to output a unique NFT, and you're not going to know what the NFT looks like before you mint the token. So, for example, we can like iterate through possible outputs. So if I press randomize here, what's going on is we're just sending in like virtual parameters. So we're like virtualizing a transaction. So virtual transaction hash, a token ID, block hash, that sort of thing. And we're inputting it into the script that the artist uploaded. And this is outputting what you see here. So this is like an example NFT that you could mint. So before Sarib is going to walk you through actually like deploying a collection like this, we're just going to mint one. So press mint here. This collection is on Goerli. It's going to ask me to pay a small fee, which I will happily do. And as you can see here, we have a pending transaction. And what's happening in the background is Highlight's going to pick up this transaction and then pass these mint parameters into the script, and then it's going to output a render through a rendering engine, and that metadata is going to get assigned to our token. So this should complete. It's happening right now. Once it completes, you can view it on a marketplace, on Etherscan, kind of whatever you want. But you're not going to know what it looks like. It should sign right about now. There we go. So that's kind of the output. Cool.
Yeah, so we've already gone through the actual mint page. What we're going to go through now is the creation page of this, basically how you end up with that mint page at the end of it. As we're going through, we'll go through the technical details of it, what basically happens in the background to end up with, or how we capture the image or the traits of the token. So I'm going to go ahead and create a collection. So this is basically, we provide different types of collection, goes from generative to series to open edition, limited edition, and one-of-one, which is basically auctions. The one we're going to focusing on is going to be the generative series. So I'm just going to go ahead and create a collection. The first page you see is basically just, it basically takes you through what's needed to render generative art based. One of them is index.html, which is basically your art, and that's what's rendered in an iframe. And then you also have the Highlight gen script, which which I'll go through the details of it. But all it does is provide a bunch of attributes which are related to the transaction. The creator can decide when they want to capture the image, the attributes of the token, and everything. So again, there's an example project that you can actually download, so you don't have to write the script yourself. You can just play with it. But yeah, let's go ahead. I'll just take you through the Gen script. So this is basically, so it's going to be open source soon, but for now it's kind of like in restricted mode. But I'll take you through a few of the methods of the Gen script that it provides. So as Ishan was mentioning, that we basically virtualize a transaction when you actually mint something. So we got two methods, which are generate random hash and generate random address. All they do is basically just map through alphabets and create a random transaction. So you don't have to actually create a transaction. It'll just create a random transaction provided to your script. And in the end, you can actually see what the output of the art looks like. As you keep going down, so the two main methods that we use here these are both open source XMR3, which is a hashing algorithm. It's available anywhere in the public repository, and then SFC32. What we do with this algorithm is that when you actually call, so one of the main methods that you call on the script is random, which works like math.random if you've ever played with. It gives you a random number between 0 and 1. But the way we do it is basically it's a pseudo random number generator. It takes a seed using these two algorithms, and the way it works is if I go to the seed method, it's gonna take in. So it's going to take in the hash and the token ID to generate a seed, and then the seed that gets inputted into pseudo-random number generator, and you have a random number, which basically every time you input the same transaction, you'll have the same art. So what happens is when you mint, we basically provide the same transaction hash, block hash, and all of those values. So that gets encoded on the chain. So every time you open that URL, you'll have the same art on the blockchain. In terms of creators, the two main methods that creators are usually concerned with, or they have to play with, are the capture preview and set attributes. What they do is basically capture preview is if you've ever gone on OpenSea, you've looked at an image of a token. That's what capture preview does, is that you can actually call this method anytime in your script. That tells Highlight that you're ready to capture an image for the token. We take an image of the token and upload to OpenSea, and that stays there. And same with set attributes. We take the attributes, we basically upload that to OpenSea, and then you have that encoded on chain. So going back to the creation process, I'll just get started with a random script. So I have a bunch of demo scripts. I'm just going to run through one. So I'll take this. It'll basically upload that to our centralized server, and at the same time, we use Arweave as our decentralized server. It uploads that to Arweave, and it stays there for permanency and then for validity of the code. Again, I'll go through, so once you land on this page, it's basically a test script page. You have your P5.js JavaScript file, which renders the art. So this is basically what the code renders. And then these are traits on this side, which we capture in live. So if you actually refresh or change the attributes, so if I'm going to randomize it, the traits are captured using our rendering engine with the script and a virtual transaction. So every time so as a creator, you can actually play around with changing the hashes, transaction hash, block hash, and you'll see different script, different traits, and you can just basically validate your art as you want it to be. Again, you can not only randomize it, you can actually input a custom hash, which will come in handy when we go to the next step. So if I keep moving forward, this is one of the key pieces of the generative art. Addition size, you can put it to anything. Like I'm just gonna go with 20. But this part is what allows the creators to say that they have a set of hashes that they want their art to use. So you can have a creator can say like, I want only these 20 set of hashes to use for my art. So whenever a mint happens, we pick randomly from one of those 20, and we assign that to the metadata. And that makes sure that whatever the art the creator wanted is basically just given to one of the collectors. We'll go through the details of like how that happens, but I'll just give a demo of like what that looks like. So basically as a creator, you can come here, you can say, I like this one. So if you click basically add, it adds to the selected hashes, and you can keep on changing, generate more tokens. They'll take different virtualized transaction, and you can keep on adding them. So you build a list of transaction hashes that basically the collectors would use for their art. Just going back to the details of it. So the way it works is basically you have, so we've already gone through this part, which is that you have a set of hashes, but we have a basically EVM data manager, which listens to live events on contracts. Whenever an event happens, let's say a mint happens, we pick that event up, it processes through our pipeline of transaction service. And when it ends up at this service, what it does is that it basically knows that a mint happened and what was the transaction of that mint. So it grabs the transaction details from the EVM chain, let's say Optimism or Arbitrum or any of the chains. And then it uses those inputs, which would be transaction hash, block hash, token ID. And it uses the Mulberry 32, which is, again, open source algo. It inputs those values into the algo. And this is the algorithm. And then it outputs a number. So the number can be whatever your collection size is. So let's say I just inputted 20. If I input these transaction hash, block hash, I'll get a number anywhere between 1 to 20. Given that number, I'll just use this list of hashes that creator wanted and just pick one of the transaction hash and use that hash for the art. A few key things about this whole process is that this algorithm is independently verifiable, which means that the algorithm is publicly available, the transaction is available on chain. You can basically run the same algorithm over and over and get the same output. So even though it's running centralized, you're always free to just verify that you got the art that you were supposed to get. The second part is that we guarantee processing of events in order. What that means is if you minted a token first, let's say you got token ID 1 and someone else got token ID 2, we make sure that the transaction of token ID 1 gets processed or gets the art first, then the token ID 2. That's important because there's a point where a collision can happen. So let's say someone gets the curated hash number 1 and another one gets the 1. So you want to make sure that the first one, who is the valid recipient of the art, gets it before the other one. So this is basically two key details of our algorithm and how it basically assigns the metadata. So going back to it, I'm just going to hover through it. For simplicity's sake, I'm just going to discard this. So I'll discard the select outputs. I'll go through the next step. This is, again, another one of the point where the creator can validate what they're actually trying to capture is actually equal to the live view. So this is the art being rendered in an iframe on the live view. So it can be basically anything. It can actually, right now it's a static image, but it can be moving image. But the preview image would be the one that's a PNG or JPEG or something. And that's what we capture at runtime. And these are the values that the creator has, so they can provide a delay. So if your script takes longer to run, you can say, like, I want it to capture up to 20 seconds. You can change those values. You can change the image resolution. And once you validate the art is valid, you can go to the next step. At this point, like, Ishan will come and talk about the details of the protocol.
Sweet. Thank you, Sarib. All right. Yeah. So we ran through all the generative art stuff. Now let's deploy the damn thing. So we're going to just configure a bunch of details about the collection, configure details about the mint. You can deploy this collection on a bunch of EVM chains. We support 5 right now, but we're going to keep adding them. For this mint, we're just going to go with Goerli. You can basically customize like whatever you want about the contract, add it to the filter registry, whatever you want. We'll just put in some dummy values for this. Waterloo 2023. Upload a custom logo that represents the collection. And you can also make the tokens on the collection non-transferable. And the way that this works is that we have, like, the collection that you deploy is highly modular. So you can swap in, like, pretty much any behavior you want to define how the NFTs on your collection operate. So coming here, the collection that you actually deploy is, it basically can refer to a bunch of modules. So almost anything that you want about the collection that you want to modify, like the behavior, you can. So whether that's burns, transfers, how the metadata is rendered, how the metadata can be updated, how the royalties can be updated, how the NFTs can be minted, like what you can have your own custom smart contracts or use some of our modules and then swap it into the collection and then swap them in and out, move them, that sort of thing. So a couple of interesting things about this is, one, because you're swapping in essentially your own code, you can introduce like any behavior, right? So like any conceivable like logic on chain, you can swap it into your collection. So that takes collections from like having, you being able to configure stuff about like the who, like who can mint this NFT or who can update metadata, to who, what, where, when, right? So because you're writing custom code. Another thing about these modules is they're what we like to call composably autocratic, which means that they can like define their own behavior about if they can be swapped or if they can be removed. And like a second order consequence of this is that creators and collections can define a path to gradually decentralize the collection. So like an example of this is, let's say when we first deploy this collection, we have a really simple module for the metadata. The metadata is frozen. Nobody can update the metadata, and only the owner can swap this module out. And then the mint happens. All the NFTs are distributed, maybe to each one of you. Everybody owns the NFT. And then the owner can swap this module out for a more decentralized module, right? So module 2 now says that if all the holders of the NFT on the collection vote on updating the metadata to something of their choice, they can. And also maybe if they vote, they can also vote to swap the module out. So you've not just decentralized who can update the metadata, but you've also decentralized who can define the behavior of who can update the metadata. So it's kind of like a meta decentralization. And then, maybe after this, they vote to also swap this module out for an even more open module. So here's like a really quick sample implementation of what a module looks like. This is Solidity, if you're familiar. I'll zoom in just because it might be a little small. So like can update metadata, like this example implementation, what it says is all the holders of the NFT, if like over 50% want to update the metadata to something, they can. Also, they got to do it before a certain time. That timestamp is also an Easter egg. It's a Unix timestamp. I'm first one to figure it out. I don't know. I'll give them like that amount in GUI or something. But there's also can swap, can remove itself. So this is like the composable autocracy part. So in this example implementation, this module is like fully locked in. Like this behavior is locked into the collection. And then finally, you can define behavior about transfers, right? So like here, we wanted to make our collection non-transferable, so all the tokens are, in this case, consensually non-transferable. Sweet. So coming back to the collection creation. All right, so final page before we deploy the collection. Now we're going to define like the mint details. So you can sell each of these tokens at a fixed price, or you can use a Dutch auction, which is a schedule of decreasing prices. But we'll keep it simple. We'll go with a fixed price. Maybe we'll make it free. You can define kind of all these like mint parameters, when it starts, when it ends. Maybe only let each person mint 2 tokens. And then something really interesting we have here is we have this idea of like gated minting. So you can create kind of these like really complex gates that restrict who can actually mint on the collection. So let's say, let's create a gate, call it demo, and you can add like a bunch of these conditions. So maybe the first condition we want to add is only like holders of Bored Ape with a certain metadata attribute can mint on this collection. So we can like go to this condition, come to the Bored Ape kind of OpenSea collection page, paste that in. Maybe, I don't know, Bored Apes with like a purple background can mint on this collection. And then we can add another condition like holds a minimum amount. So like you have to own that Bored Ape with a purple background, and you have to hold a minimum of 2 ethers. So it's very like elitist to mint. But we can change this to all, so you can switch between like an or clause and an and clause. And so we can just create this complex gate. And now the gate is applied to the mint. And so the way that our mint works is creators can actually like gaslessly swap this gate in and out. So this is a good summary of our mint architecture. This is what it looks like on chain. The mint module is a smart contract. The collection is another. That's the one that's a smart contract we're going to deploy for you guys. We have this concept of mint vectors. So mint vectors are just like different ways to mint on the collection. So you can parallelize a bunch of different sales, right? So you could have a mint vector that's like only Bored Ape holders can mint at this for a free price. You could have another mint vector that's going on at the same time that's like for a public mint. So it's analogous to like mint phases on a normal collection. So at the top left, you see like the user comes to highlight. They want to mint on the gated mint. We evaluate their blockchain account, make sure they can actually like mint on the collection. And then we construct a key. We pass the key into the module. We unwrap this on-chain with EIP 712, and then we mint on the collection. And because these vectors are off-chain, the creators can actually come in and kind of edit the mint config without a transaction. So that's like a nice detail for them. Sweet. Okay, so I think we've configured the mint. We can just review everything that we've created and then deploy this collection. MetaMask is going to pop up. Sweet.
Yeah, so once the mint is actually deployed, we're just going to quickly go through, I think we're running out of time, but we'll just quickly go through the actual mint page. So if you land on the mint page, we're done full circle where we started from. You have the actual art, you can mint it because it's a gate. Like, I don't think I have that much either. So I'm just going to go ahead and remove that gate, which kind of serves as a purpose to show that. So I go ahead, it's kind of happens in a gasless way. So I'm just going to go ahead, save it. And once that's done, I'm just going to go back to the mint page and I'll be able to mint it. Again, same process. Once you mint it, you go through the transaction, it captures the attributes. And just to round it off, the way it happens is we have a rendering engine and metadata logic. Again, when the transaction happens, we capture the transaction values, whether the capture details. It goes to a rendering engine, which runs Chrome headless, and it relies on the attributes and capture preview. It outputs an image URL, animation URL, attributes. And at this point, what we do is basically we take these attributes, we upload them to RV for decentralization, and then we upload them to S3. The way we do dual upload is basically we want to keep updating the tokens, but we want to also, but anyone can verify that what values that are on chain, they stay on chain, and nothing from the centralized server changes anything. So we do a dual upload so you can verify anytime the metadata of the token. But yeah, so that's basically, again, the capture happened, it showed the image, and it went through it. But yeah, at this point, like that was just basically a demo, but we'll talk about, there's a competition that we're running, and Ishan will talk more about it.
Sweet. Okay, so we're almost done. We'll take questions. But real quick before we take questions, so we're running a competition for the hackathon. There's $5,000 in prizes. You can win up to 3,000. It's really simple. All you have to do is we'll give you access to our beta platform, which you can find this form on the ETH Waterloo website. But just make a generative art collection with the same like flow that we just ran through. We're gonna judge you on creativity, kind of any like cool thing that you input in there. And also we talked about the composability of the protocol. So if you want to introduce like your own modules, if you know Solidity, or you can use our modules, you can get creative with it. You can win $3,000. And also the winner of this competition is the official ETH Waterloo NFT. So whoever wins, your collection, we're going to distribute your NFT to all the attendees at the end of this hackathon. Yeah, and there's like, if you go to this page, like if you're new to generative art, you can kind of learn how to do it. You can get a collection set up in like 5 minutes. It's pretty simple. Sweet.